Hi, I'm Greg Olson. I'm TSI's Senior Industrial Hygienist and the Global Product Manager for the Health and Safety Instrument line. Welcome to another edition of our product training videos. Today, we're going to be going over the DustTrak DRX, desktop and handheld instruments. We have two models. Specifically, what we're going to do today is to talk about and go through a size correction factor calibration, also known as a standard calibration for the DustTrak DRX. This calibration utilizing a size correction factor is unique to the DustTrak DRX series of instruments. It is not possible to do this on a single channel photometer. Specifically, what we're going to be doing is looking at a change in the ambient aerosol size distribution to the size distribution of Arizona road dust, or A1 test dust, that the DustTrak is calibrated to. And how we're going to do this is very simple. We're on the main screen right now. We've also zeroed the instrument already. That's something that's critical to do before you do a size correction factor calibration in real time. And we have a PM 2.5 impactor that has been greased up already. It's ready to go. And now let's assume we're doing this in the work area or the ambient area that we're going to do our sampling. And we're concerned that the aerosol we're going to measure may be different in response than the Arizona road dust, the A1 test dust. So we're going to utilize the lower setup screen here. I'm going to press the setup tab. And across the left side of the instrument, we're going to see another row of icons come up. And we're going to go to the user cal icon. Now, from the upper drop-down menu, we're going to look at the top one is factory cal. That's the factory calibration that was put into the instrument. And then there are 10 user calibrations. And in these user calibrations, there are two different correction factors. One is a photometric correction factor, and the other is the size correction factor. I'm going to select one, and when it says test 1 through 10, you can change the nomenclature to be whatever you'd like it to be. A calibration factor for wood dust, for example. A calibration factor for welding fume. A calibration factor for ambient dust. Okay? Whatever you want that to be, you can go and change it. You have a photometric cal factor that's 1.0. That's the factory set point for Arizona road dust, and the same thing for size correction factor. It's 1.0. So I want to do a real-time size correction factor. The reason for being able to do that is you don't have to take the time to do all the photometric sampling, which may take several hours to a couple of days to complete enough samples. Now, you can do this in real time. So what we're going to do is we're going to select size correction factor, and we're going to come down here to custom calibration. A new window will pop up, and on that window it's going to say sampling without an impactor, sampling with an impactor, and then at the end of the procedure it will come up with a new correction factor. So when you sample without the impactor, you're looking at the total dust coming in, or the full detection range of what the DustTrak DRX can see, which is 15 microns down to 0.1 microns or 100 nanometers. So you're going to sample without. Then you're going to sample with the PM 2.5 impactor, put on the instrument, and what that's going to do is it's going to cut the aerosol size at 2.5 microns. It's going to take another representative sample of 2.5 and less aerosol down to 0.1 microns, and then it's going to compare the total versus the PM 2.5, and it's going to come up with a correction factor, looking at any size distribution differences between the ambient aerosol you're measuring and the Arizona road dust that the instrument was calibrated to. Now, this sampling can take anywhere from 2 to 10 minutes per sample. So what I mean by that is 2 to 10 minutes looking at total dust and 2 to 10 minutes looking at PM 2.5. The reason for the difference in the time is if you're in an environment that is, say, fairly dirty, okay, has a lot of aerosol, it's going to take a shorter period of time to get a statistically valid sample. If you're in an environment that has a very low concentration of aerosol, it's going to take a longer period of time to get enough statistical information to give us a good sample base to compare the total versus the PM 2.5 fractions. Now, when this process is done, okay, you're going to come back to this main screen, and instead of 1.0, there's going to be a correction factor put in there. And that correction factor, if it's, I typically tell people if it's plus or minus 5%, if it's within that from 1.0, I would just leave the correction factor at 1.0. You're really not going to change the instrument's response at all. But if that correction factor comes up less than 0.95 or greater than 1.05, meaning you're starting to get a window of difference in accuracy where it's more than a 10% delta, you'd want to accept that information. Let's say that your new cal factor came back at 1.40. You would definitely want to go and accept that, okay, save that new number, and then you want to go and enable that user cal. So on this bottom row here, it'll say user cal off, and what you want to do is toggle it so that it is on, and then you save that. And now this user calibration with this new real-time size correction factor that you just did is input into the instrument. This is going to be the new correction factor, so it would be 1.4, for example, all right, for size correction factor, and your photometric correction factor is still 1.0, but that is what the instrument is now going to run at, okay? So now all we simply have to do is to go back to the main screen. It's going to update the memory, so now it's inputting in that the size correction factor is 1.4, the photometric correction factor is still 1.0, and now when you press the start button, the instrument turns on, the instrument's response has changed to the size distribution of the aerosol in the environment that you're monitoring. So a really useful tool when you don't necessarily have the time to do a long drawn-out photometric correction factor. Okay, not to say that that isn't important to do and very beneficial as well, but if you're just looking for a quick solution to being able to do an on-site real-time correction factor to the instrument, you're able to do that with the DustTrak DRX. There aren't any other aerosol monitoring instruments that are able to do that. So definitely a benefit here of being able to adjust the instrument's response instantaneously and get better results. So I hope this information was helpful. Certainly don't hesitate to call us or go to www.tsi.com for further information. Thank you, and we'll see you next time.